and too many things to do, of course. Just a moment, I will share the video. Sharing and start. And too many things to do, of course. Just a moment, I will share the video. Sharing and start. And too many things to do, of course. Just a moment, I will share the video. Sharing and start. And too many things to do, of course. Just a moment, I will share the video. Sharing and start. And okay. Too many things to do. Okay, there is an echo. We are live now. We are live. So please, everybody that's not to speak now, mute your microphone. Okay. Joe Pelton, the floor is yours.
Okay.
To start our meeting.
Welcome. This is the first of the Living in Space initiative programs. And we welcome many scores of viewers from all over the world to this event. And I would like to note, my name is Joe Pelton. I am the Dean Emeritus of the International Space University. I am the founder of the Arthur C. Clarke Foundation and serving as chair of the steering committee for this new initiative that has a baker's dozen of memberships. And we have a ops committee that has basically made this event happen. And critical to that has been Adriano Autino of Italy, who is from the Space Renaissance International, who has played a key role and is our producer today. Next, I'd like to introduce Gary Barnhard. He is the representative for the National Space Society, for Moon Village Association, and his own Space Development Foundation. Next, I would like to recognize the person who has been our webmaster, who has brought, he was the founder of a group that is known as Life to and from Earth. And he brings with us a number of younger space scientists and engineers. So these members of the ops group, I would particularly like to thank for making this event and bringing all these distinguished speakers together. I would just like to know that this is a new initiative that really started just a few months ago, and we have big plans. In addition, we have a workshop that will be on February 13th, and hope you are registered or will register and go to our website at living-in-space.org and register and stay tuned to our various events. We have a workshop that will go into the topics we'll be hearing today in much greater depth. And in 2026, we hope to have a conference. We hope to produce videos. We hope to produce social media campaigns publicizing our activity and articles. and many other things. So stay tuned to our website and welcome. And I would like to introduce our first speaker with this introduction, a long-term friend that we have been working together for many decades. And he is doing something quite exciting. My mentor, Arthur C. Clarke, once said that to probe the possible, you must venture into the realm of the impossible to see what can be done. And Peter is probing that range of the impossible to make things possible. So Peter, who is the director of the Space Elevator Development Corporation, is going to tell us how it can all be done. Peter, unmute and please tell us. Elevator Development Corporation is going to tell us how it can all be done. Peter.
Okay.
Unmute and please
sharing.
Tell us.
Can you all see that? I hope. Okay. As you can see on my board there, I've been there and done that for 52 years.
Is going to tell us
with launch
how it can
operations, designs,
Peter.
manufacturing, and design experiences.
Unmute and please sharing. Tell us.
Can you all see
Peter? Peter,
Okay,
Peter.
okay.
Sorry.
See,
Sorry to interrupt you.
My board there, I've been there and done
Okay,
that.
I think you have
Is going
think-
to tell us
launch
how it can
you have an open window that is
design,
repeating.
manufacturing, and
Okay.
design.
Mute it.
Everybody should go mute.
Can you all
Sorry,
see?
Peter. Peter,
Okay,
Peter.
okay.
Sorry. Sorry. Peter, you have an open window that is showing our meeting, and you have to mute that to put the volume at 0. Hello? Okay. Now you can unmute, maybe? Peter, you are mute.
Okay, let's try this now.
Okay, great.
Okay,
So
now I'm going to share and we'll start from there. Sorry for the problem here. You know, it happens. Let's see, where's my, okay, I got to go over here and go full here. There we go there. Now we go over here. Share. Okay, that should work.
Yeah.
Okay, good. I'll start now. It turns out I have done like 52 years in the space arena, and I've had quite an exciting ride, and I've been looking at space elevators for 43 years. So I believe in my heart that we can build a space transportation permanent infrastructure in the near future. We have the material now. So what we need to do in this short talk, is talk about the needs of the customers and what the benefits are of the space elevator. It turns out that I believe all people who want to live in space require the modern day space elevator. What is a space elevator? It's basically a counterweight on the end. We call the apex anchor, a 100,000 kilometer long tether. We have the material for the tether, so we feel like we can build the modern day space elevator. If you look at the needs of the future, if you look at Mars, Mr. Musk has said 1 million tons to the surface. If you look at the L5, it's 20 million tons to the L5. No matter where you're going as a living settlement, we're going to need a huge amount of mass. And if you recognize that rockets only provide less than 2% of the mass on the liftoff pad to any one of these locations, we're really in trouble. So the modern day space elevator has a material that's called supergraphene laminate. It's coming out of the laboratory. So we're ready to enter the engineering phase. We call ourselves the green road of space because we don't leave any debris and we don't burn any rocket fuel in the atmosphere. So we want to join the advanced rockets. If you see the image on the left, we want to be a partner of rockets as we go forward. So the major strength of the space elevator is delivery of mass to far destinations. And here's just a picture of the material. We've got many, many articles that have been written that says it should be ready for a space elevator in 5 to 10 years. Here's a basis for it. There's 2 magazines of the British Interplanetary Society. This is all at our body of knowledge on the website, www.isc.org. And so you can catch up with where we are. Now, here's the key. If we go to 2044, when we want to be operational, we have 6 galactic harbors, and they would provide 70% of the mass on the ocean would be provided to geosynchronous and beyond. That's like comparing to rockets at 2%. So the real kicker is if you want to build anything in space, you really need a space elevator. The apparatus looks like this. We've got a long tether, it's attached to the ocean, and we've got an apex anchor at the top. If you're at geosynchronous on this, you're going at the velocity of geosynchronous satellites. If you go up to 100,000 kilometers, you can get to Mars in 61 days. If you go to 163,000 kilometers, you leave the solar system without any rocket fuel. Arizona State University and local here did a study with us on how we can leverage space elevators for Mars. We showed the fastest travel is 61 days. Now, some of them are 120, the average is about 120, and some are 400, but who cares how long the hammers and nails take to get there? We have rapid transit. Plus, we can release every day toward Mars. If you go by rockets, it's every 26 months you get an opportunity to send your flotilla. But we can launch every day, and we do massive tonnage, and we can build large spacecraft at the apex anchor. Well, how is this possible? You release from the Earth going really, really fast. You're not going on the slow way to Mars. You're going on the fast route for 61 days. The students at ASU decided they'd even come up with a bus schedule. So we're talking on-time delivery. We're talking a bus schedule to Mars. Think of that. That can be done when you have a permanent space architecture, an infrastructure that's up there permanently. So what are the benefits of a permanent infrastructure? Daily, routine, efficient, inexpensive. If we're moving people and logistics, we want it to be an infrastructure like a bridge, not one-time events. Okay, what are big advantages that can help solve the needs of the customer? We're a green road to space. I mentioned that. We want to mention that a bunch here and there. But the liftoff is compared to the Apollo program, who delivered 0.5% to the surface of the moon. Now, the rocket equation has not changed. Mr. Musk and his guys and Mr. Bezos are going to have reusability. That'll make it cheaper, easier, more reliable, a lot more launches, but it ain't going to improve the delivery statistics. So we can do 70% from our ocean dock to release points. So our benefits really have all kinds of sides to them. One is the total mass. Here's the buildup of mass we see, unmatched velocities, and we can get there a lot faster. So why is this apex anchor kind of interesting? We just did a 18-month study. We showed that if you have an apex anchor, read that truck stop, you can assemble things up there and have a huge spacecraft at the apex anchor for scientists to release to any part in the solar system. So instead of being restricted to like 2,000 pounds, you can have, say, 150 tons going for science missions. Okay, what are we waiting for? The answers are so obvious. We have unmatched velocity, apex anchor assembly, unmatched mass movement, unmatched efficiency, and on top of that, it's a green road to space and won't ruin the atmosphere or destroy our environment. So we have a tremendous amount of characteristics that are inherent in a permanent space infrastructure. These things translate to satisfying customer needs. So people who want to live in space truly should start thinking seriously about doing permanent bridges up there instead of individual events. Here's our summary, which is we're transformational. We change the way we think of space. Okay, we want to partner with rockets. Rockets move people through radiation belts rapidly, and they also do very good low Earth orbit. We don't do that. We're the green way to space. We're a huge place moving 170,000 tons per year. And so I'd like to close with a little statement that says, indeed, when looking at the needs of the customer who want to live in space, the modern day space elevator really must become operational. Thank you.
Thank you. Quick question. How can your structure stand up to the radiation in the Van Allen belts? And where are you in terms of your climber robots development?
Okay, that's two questions. One is the radiation. We don't really give a rip about the radiation if we don't have people. And we don't plan on doing people for the first 20 years. We want to do we want to do just logistics because that's our strength. In the future, of course, we'll have 2 or 3 strands and we'll have a big 200-ton climber and we'll put people there and then we'll worry about radiation. So radiation is irrelevant. On the second is the tailored climber. We've designed that. We just finished a 3-year study that showed with today we could build a tethered climber with the materials today that would have a 50% payload to total mass. And we can do that today. Now, there are a lot of ways to improve that to get to what our estimate is, which is 70% payload, 30% tether climber. But yeah, we're well along on the tether climber. That's just a stupid satellite, Joe. Anybody can make that.
All right. Well, thank you very much. Let's now go to Armin, who is taking on another impossible subject. I've written a number of books.
Sorry, Joe, I think Henk Rogers has something to ask, maybe? He has
I have a quick question. The angular velocity of payload at the equator is what, 24,000 miles per hour? And then
No, at the equator, it's going the velocity of the Earth.
Yeah, the velocity of the Earth. But then if you're going to geostationary, that velocity is much higher.
Right,
you
it's
have to
3,000
accelerate that payload as you go up.
Yes.
And how does that work? I mean, is that
you climb up, and part of the energy you're putting into it is adding horizontal velocity. So your energy is being consumed by both going against gravity and increasing velocity. So it's just an energy equation. You got to have enough energy to do both of those. You're not just going up, you're compensating, you're adding velocity horizontally.
Okay, I think we need to move on to our next speaker, but thanks for the question, Henk. Armin is taking on a topic, as I say, I've written a number of books, but I've never been courageous enough to take on the issue of financing in space. And that's the really big question. And we'll give you more time at the workshop to address this in more detail. But thanks, Armin.
Brilliant. Thank you, Joe. Thanks for the introduction. I'm actually quite happy that I'm very happy that my short talk will be following Peter's, because he spoke about fundamental things that I will touch upon in this presentation, specifically mass to orbit, but also he referenced customers, right? How are these mega projects, whether it's permanent infrastructure that reduces the the carbon footprint or the footprint of every rocket climb, so to speak, but in general, not just in terms of the green impact, It's also how are we going to finance and where we are today in terms of the space economy, and whether that actually can take us to the type of exploration and settlement that we often talk about in this circle, but in general as well. So the subject, the title is The New Space Economy and Outer Space Exploration and Settlement, and it's the highest, so to speak, the most abstract level or the beginning of my argument. It's not the whole argument because of time constraints. So the first thing I'd like to do, and I want to do this because I want to make sure I express it clearly and in the minimum amount of time. I'm going to read the paragraph from my recent book, which was supposed to be released by now. I was hoping that by today it would be already out, but it looks like it will take another couple of days. But this is imminent. It will be released by Palgrave Macmillan in the next couple of days.
It's on Amazon right now.
Yes, it is, and it's available for pre-order. It just hasn't been released yet. Yeah, it will be released as of, yeah, it is available. So this is a small paragraph from the second chapter of the book, which is called The New Outer Space Economy. So I'm going to just jump in. So investment banks and large consulting firms have had their eureka moment. We are in space and it is good business. Never before have the big firms felt so inspired by the final frontier. Reports are being published by the who's who of banking and consulting, and they are all full of positive expectations. The space economy, as they call it, is growing fast. While the excitement and positive expectations are grounded in actual economic factors and data, they do not necessarily imply that investment bankers and consultants are eagerly waiting for Artemis to take us back to the moon, or that they are holding their breath for SpaceX's first flight to Mars. The buzz around the space economy is not really about outer space exploration and settlement, but rather about the growing operationalization and commercialization of outer space infrastructure for Earth-based and delivered products and services. This is pretty much the highest level, abstract level summary of the current space economy. There are many sources, many estimates about what this space economy, the size, and the extent of this space economy. The Space Foundation has some estimates of revenues, the International Satellites Association, Producers Association, ISA has estimates, but the one that I use, I refer to many of them, but the one that I focus on is the one that was recently published in 2024 by the World Economic Forum and McKinsey. Now, according to the World Economic Forum and McKinsey, in 2023, the space economy pretty much achieved 630 billion value. And their estimation is that by 2035, the space economy will grow to around 1.8 trillion or 1,790 billion, with a 9% per year annual growth, which far exceeds other sectors and economies. Now, this is all fine, but it's not really contextualized. And what I do is I want you to see this in context. Now, this 630 billion figure of the space economy, if we were to compare it to world GDP in 2023, we're talking 0.6% at 104 billion. 104 trillion. Now, the question here, and the second one is, in terms of the comparison, is with global wealth in 2023. Now, I've used the IMF annual publications and the UBS, which used to be Credit Suisse, Global Wealth Report. So as you can see, the space economy is tiny in terms of in the broader picture. 0.13% of global wealth in 2023. Now, there's two fundamental elements, obviously, that we have to take into account when we look at the space economy, which define and structure these figures. And that is, first, because of the sensitive nature of the technologies, this sector is always under strict export control, whether it's ITAR, DDTC, EAR, CCL, in the US and elsewhere. This market isn't as like any other consumer market. So that is one element that must be taken into account. The second one is that it is actually very broadly defined. According to the US Bureau of Economic Analysis and OECD, both the commonly used measure of the space economy, the space economy, according to the US Bureau of Economic Analysis, is defined as the space, it includes goods and services that are used in space, so that's one category, or directly support those used in space, second, and third, require direct input from space to function or directly support those that do, and are associated with studying space. Now, I'm not going to get into this very broad definition, but I'd like you to remember the third point. Goods and services, public or private, that require direct input from space to function or directly support those that do. I'll come back to this in a minute.
Well, we need to conclude, though, so can you wrap up, please?
Yes.
Sorry.
Okay, so basically the point here being that, is it already 10 minutes?
Yes.
Okay, sorry. So, but this reality, the space economy, the industry as such, as a sector, we're talking about in comparative terms, not just in the grand scheme of things, but if you compare to very specific sectors like the military spending, like oil and gas revenues, and even global advertising spending, is much smaller than those sectors. So the species on a planetary level spends more on defending itself from itself. It spends more on trying to sell goods to itself than on building its collective future in outer space. And my conclusion and the argument that I develop, and unfortunately it's a bit short for me to go into it now, is that all these elements are due and are founded on the bottlenecks that are brought to us from in our financial value framework, in our financial mathematics, and our monetary architecture. So without addressing those three challenges, the space economy does not have neither the size nor the reach to be able to take us much further into outer space. So thank you.
Thank you very much. Very short, but people can always buy your book on Amazon. So next we go to our third speaker, who needs very little introduction, our distinguished CEO and founder of the Space Renaissance International, Adriano.
Okay, it's my turn. So let me share my presentation. Is it here? Okay, so trying to go quickly, just let me mention a couple of initiatives that the Space Renaissance International is carrying ahead. The first one is a proposal that we made to both the Artemis and ILS to plant a UN flag on the moon. Whoever will be the first one to put the boot on the moon, first thing to do to plant a UN flag before planting their national flags. This is to represent that we are going to the moon in the name of all humanity. Okay, I want to be very quick. The second thing is the initiative to add an 18th SDG to the 17 SDGs of the agenda for sustainable development, because any further development on Earth is not sustainable, and therefore what we need is to have civilian space development that will sustain all of the other SDGs. So this is an initiative that has now 106 organizations supporting, and is running since 2 years. And also this year in 2025, we will make significant actions at COPUOS and at the UN General Assembly. Okay, so going ahead. What we can say now is that when civilian space development will start, the space traveler will not be astronauts. They will be normal traveler, just like now we are flying on air flights, normal airliner. We will fly to space, to orbit, and to the moon, and to the cislunar region without any astronautical training or skills or competence. This is a change of paradigm that is to be understood, and also to be taken the correct initiatives to make it possible. So we are at the dawn of space tourism, and there are also some legal aspects that we're not sure if they are correctly tackled by now, because I'm afraid that the space tourism so far, they sign a liberatory that they renounce to their normal rights that any traveler, civilian traveler, has on Earth to go to space. So this is something that should be announced. So there is a progression in the let me say in the requirement, the mission requirements, from the exploration to space tourism and to the expansion and space settlement. The main challenge is, of course, to a meaningful downsize of the cost of transportation from Earth to orbit. And this is now going ahead with reusable rockets by SpaceX, Blue Origin, and so on. Not the same we can say about the other big challenge to protect human life and health in space. This is also a very big thing to do, and so for the protect human life from cosmic radiation and from the damage of lower gravity. So start to work with simulated gravity is very, very urgent too. This is Scott Kelly, a NASA astronaut that remained 1 year on the ISS and reported terrible health problems when he came back to Earth, about circulation, blood circulation, about cognitive problems and equilibrium, and a lot of things that are well documented in several papers that were developed by the scientific observer of this thing. Okay, so we know effects of low gravity on human health are very, very heavy, as experience of Scott Kelly has demonstrated, and other astronauts. And the effects of cosmic radiations reported by NASA are also very, very important. And the cosmic radiation, so the space radiation comes from the sun, the solar radiation, and from the galactic environment. So the supernova explosions and so on. So this is if we are serious and we really want to start living and working in space, we have to face these problems with more priority, better priority. Strong acceleration is another factor that affects human health, and that should be adjusted, no? To have vehicles for passenger transportation that don't accelerate more than 2 or 3 Gs, in order that anybody or us can go and fly. So why it doesn't work anymore. Oh, sorry. Some problems with my PowerPoint. Oof. Okay. Sorry. Okay. Dangers of unsafe re-entry in the atmosphere. That's another problem. So also this point should be studied, investigated, and to find new technologies for the re-enter in Earth atmosphere in order to protect people, travelers, from the high temperatures and from the very bad conditions that are experimented during the 26 minutes of very hot re-entering in the atmosphere. We also remember the Columbia shuttle crew that they were heroes disappeared in that unlucky mission. And yeah, so this is an environment on the following the O'Neill designs of stations, orbital infrastructures, rotating infrastructures, so they can simulate 1G. And also we okay, because what is the problem? That we also need green environment. We need vegetables in space. We don't want to live in iron cages for months and for years or for. I took as an example the planet Trantor by the Isaac Asimov Foundation trilogy. That was a planet completely artificial, where nature was completely suppressed. So we don't want space habitats made in this way. We need our normal biome, earthly biome in space. The concept of expansion versus exploration is very important to understand it. Expansion into space may turn out to be difficult, but do we really have other choices? No, we don't. Any alternative includes a horrible holocaust, very much worse than facing the problems of developing good living conditions in space. Our real priority is to develop other models of space settlement, allowing for optimal human habitation. Simulated gravity is key, and so is protection against cosmic radiation. But these are not the only challenges we should tackle. If we want the average untrained person to be able to travel to and from orbit, we also need vehicles and as comfortable as normal airliners, horizontal takeoff and landing, low acceleration, and safe re-entry. So, okay, for the sake of our physical and mental health, we also need a green environment in space: flowers, trees, grass, flowing waters, and animals with us. So what I want to express is that we have a progressive research strategy with health requirements growing up. So developing any concept, we always should start from humans, their rights, their health, their life, and their hopes for a better future. We work to allow people's lives to become better, not worse. There is no doubt that traveling and living in space like astronauts will be quite a poor life. An astronautic experience could be exciting, of course, for a short duration. That's the point where space tourism comes in. We can say that space tourism is an intermediate stage between exploration and the settlement paradigm. It is an intermediate state because space tourism takes care of the comfort and the health of the passenger, the civilian passengers, but in the same time it has a short.
1 minute.
Okay, I'm going ahead. I think you understand what I mean. So this is a table. Then okay, all the presentation will be available in PDF, so you can see this table with the progression of health and ergonomics requirements from space exploration, space tourism, and space settlement. Okay, cosmic humanism, okay. Space exploration are short missions, military trained astronauts, health and ergonomic low, sick. Space tourism, very short duration, civilian low trained tourists, health and ergonomic requirement medium. Space settlement, long staying, health and ergonomic requirements high. Okay, this implies an evolution of the mission requirements and of the technologies and the methodologies and so on. Okay, a spherical growing concept. Okay, this is a representation of the cislunar region, Earth and the Moon, and the Lagrange points. And yeah, explorers and settlers should be the best friends, because exploration cannot be any more supported if there will not be a robust space settlement and civilian space development growth and economical growth that can support all human activities, including space exploration. Thank you very much. Sorry to be a little bit long.
Thank you. So we next go to a speaker who is Mr. Safety in Space, who was the founder of the International Association for the Advancement of Space Safety, and he's taken a leading role in trying to organize for safety on the moon. He helped with a conference that the IAAS did with China to explore what you really need to do to achieve safety on the moon. So without further introduction, Tommaso, can you enlighten us?
Thank you very much, Joe, for the nice introduction. As you mentioned, we had, the association had in 2021 a remote conference on lunar search and rescue. Now, my presentation today, a very brief presentation, will be about the need for connectivity and the need for interoperability standard. But let's make a little bit the point why lunar search and rescue is important. You will remember that in 1969, when the NASA Apollo 11 astronauts landed on the moon, the landing was truly, the key point. However, also the ascending and returning to Earth was an important part of the mission. And there was a 10% chance of a failure of the single engine of the ascent vehicle. In preparation for a potential tragedy, there was a speech prepared for the USA president of the time, Richard Nixon, which basically said, "Fate has ordained that the men who went to the moon to explore in peace will stay on the moon and die over there." Now, they were the first one to go to the moon, but we are going now to the moon, hopefully, with different programs from different countries and groups. Now, fast forward to 2035, 10 years from now, and let's assume that something similar to what was, a feared outcome of the Apollo 11 would happen to a European crew that would have a failure of the ascent vehicle while preparing to return to orbit and Earth. Now, assume that not far away in, let's say, Earth terms, something like 50 kilometers, there is a Chinese mining colony. Now, what needs to be in place to make possible search and rescue on the moon? First of all, they need to have connectivity between the operators on the moon, between the European, the US, the Chinese, the Russian, etc. Communication, and also the ability of navigating and identifying the location of the distressed crew. To make possible for, in this case, what I assumed the Chinese miners to come and help, you need mobility, and take into account that on the moon, the maximum speed that a rover can, reach is 11 kilometers per hour. So a 50-kilometer distance that may sound rather small on Earth becomes a huge distance on the moon. You need vehicles that can transport more than a local crew, let's say, that can transport a stranded astronaut, perhaps with some problems, physical problems, etc. But even assuming that you have a connectivity, communication, localization capabilities, you have a mobility on the moon, the moment in which these European astronauts are brought to the Chinese habitat, they need more to enter. They need standard connection for the airlocks. They need a common procedure for dedusting the space suit. And even assuming that this happens when the crew is inside, you need to have the capability to intervene for helping, for example, an injured astronaut, which is a legal capability in the sense that you must be able to share medical data and so on. Therefore, the substance of the message that I would like to pass to you today is that although in the space treaties there is since 1967 and reaffirmed into the Artemis Accords the concept of search and rescue, the capability of having search and rescue, you cannot truly have search and rescue on lunar mission unless there are certain capabilities and standards, interoperability standards and legal agreements today being, let's say, developed. The message, the good news, I would say, is that following the conference we had back in 21 in cooperation with the Beijing Institute of Technology, there has been some movement into the ICG, which is the International Committee on Navigation, attached to the United Nations HOSA, and this committee will have in February of this year, February 2025, the first workshop on interoperability of GNSS system. This is the first step. There are more steps to be done, more a long road to be covered, but this is something that needs to be done, at least from the point of view of self-interest. Nowadays, we are unfortunately no longer in the era of cooperation and internationalization. We are a bit retreating on nationalism and egoism of the nation. This is an activity that needs to be done also in the perspective of self-interest. So search and rescue on the moon requires connectivities and requires interoperability to a large extent, legal, technical, and also semantic, the language, the communication, etc., all things that needs to be done today and not when it will be too late to develop them. Thank you very much for your attention.
Thank you. So our next speaker is supposed to be Jim Green. I know I've just sent him a link.
Joe, I'm on.
Okay, great. Thanks. Jim Green is a former chief scientist for NASA, but he started out in planetary and solar studies. And he and I actually have been discussing the idea of creating a magnetic shield for Earth to protect us against major solar storms, coronal mass ejections that could create a $1 trillion event, but also the very exciting idea of could we create a shield for Mars so it could build up an atmosphere as its polar caps melt. So with that brief introduction, Jim, please tell us how could we make Mars livable?
Thanks very much, Joe. Really appreciate the opportunity to talk about some of these wild ideas. You've got to investigate these to uncover all the physical problems associated with implementing them. And of course, the concept of a magnetic shield for Mars is extremely important. And very timely, I think, as we think about how overall humans will live and work on the planetary body like Mars. Let me start out quite quickly by talking about the evolution of Mars. Mars was a blue planet originally. In other words, it had an atmosphere that enabled it to be warm enough for liquid water to be on the surface. 2/3 of the northern hemisphere we believe were underwater, perhaps as much as a kilometer and a half. But over time, Mars began to lose its water. And there are now a fairly good understanding as to how that happened. A spacecraft like MAVEN, which is orbiting Mars now, has determined that oxygen is flowing away from the planet at a reasonably significant rate. And part of that is because it's a disassociation of oxygen from water. Mars actually, that water cycle got broke. So you have out of the ocean evaporation, transport, then rain. But what was happening, of course, is after evaporation, there's disassociation of the oxygen and the hydrogen. The hydrogen leaves because it's light, and the oxygen is pulled out by, indeed, the atmosphere of the sun, which includes the solar wind that's hammering the planet over time. Well, what we're finding out also is Mars had a random magnetic field. And perhaps this is one of the major reasons why the planet was able to stay in a habitable state for as long as it did early on in its history. So right now, Mars's atmosphere has reached an equilibrium. The amount of material the solar wind strips is equaling the amount of material that is being outgassed. And so conceptually then, if we could create a large enough magnetic field, how would we do it? Where would we place it? And what would be the advantages? Of course, the advantages would be to limit atmospheric escape. Advantages would be to provide a magnetic shield against high energy radiation and begin the process of what we call typically terraforming today. Well, Ruth Banford and a number, I was co-author also on this paper, talked about how to generate these large fields. And of course, the kind of field we generate that would model a bar magnet would be a current loop. Now, these current loops could be supercomputer or superconducting loops or plasma loops that then generate large magnetic fields. And so right now, we're investigating how to make these fields large enough that would provide some sort of protection. And then where would we put them? One concept would be that you put this current generator at Mars L1. This is a location 230 or so Mars radii upstream. The solar wind hits this magnetic field. Lorentz equation tells us the electrons and protons move around the magnetic field in different directions. That causes a current, cross-tail current, what's called, and a magnetic field is generated and produces a magnetotail. And it's easily able to place Mars in this magnetotail and begin the process of shielding the planet from atmospheric erosion. But indeed, as we look at other environments, and we see that this is really quite an important way to protect Mars, several orders of magnitude less stripping occurs from what's on the left, what's happening today without the shield, and what happens on the right is shown in our MHD models. And of course, how we study these things right now are all done on supercomputers. Just like you do climate change and predict what happens in the future, you're doing that in supercomputers too. And so that's what we're doing at Mars. Now, the configuration that I like the best, that provides the most protection, turns out to be 4 current loops that are placed in Mars' synchronous orbit. Now, these are the magnetic field topologies that result from that concept. On the right-hand side, you're looking down from the northern or southern hemisphere, and you can see the 4 current loops. The solar wind is coming from the right, and you can see how that produces a buffer, just like the Earth's magnetosphere does, with the solar wind having a very difficult time getting to the atmosphere of Mars. On the left-hand side, you see that same figure, but you get a cross-section of it for which you see the z-axis and the x-axis, where the z-axis, of course, is north and south, and you can see the magnetic field lines that then work together to really encase Mars in a complete magnetic envelope. This is really a major significant approach. We also know that we can change the dipole nature by changing the direction of the current, and we can adjust for any kind of storm periods that might occur, constantly buffering the Martian atmosphere from the solar wind environment. Another important effect that this has is, of course, the field goes all the way down to the surface, and here's what the surface magnetic field would look like. And by small variations in the magnetic field generated at these terminal points in Mars' synchronous orbit, you actually can provide a variation of the field across the surface, providing an opportunity to longitude and latitude yourself on the planet. So you can actually use this for navigational purposes. So these are some of the concepts that are coming along right now about how we might be able to do that and where we would place these in Mars's orbit. And once again, we're doing these simulations to understand how these environments might be able to be the best environments for humans to go and live and work on the surface of Mars. Now, to end, let me mention, I do have a book too that's out. It's a Taschen book. It's indeed photographs from NASA's archive. I did it with a couple JPLers and space historians. It's now available, and I'm delighted to tell you it was a very exciting book to do. Has a lot of wonderful features associated with it, wonderful images that I'm sure many of you even haven't seen. So thank you very much.
Jim, thank you very much. A quick question. At one point, there was some thought of using Phobos and Deimos to generate the signals from there. Was that idea totally discarded?
Yes, that's another one of the concepts. We haven't done the modeling of that. Of course, Phobos is close to Mars. Therefore, its orbital period is more like 7 or so hours. So it's interior to Mars' synchronous orbit. Deimos is exterior to Mars' synchronous orbit. So it's like, more than 24 hours in terms of one orbit. And so we haven't done the modeling of that, but even then I can tell you the fields would not be as comprehensive as they would be if we just chose 4 nice areas, Mars synchronous orbit locations and did that. Of course, one of the locations we would put right over on top of the Mars exploration zone. so that it would provide maximum protection right down to the surface.
And the idea is, well, question is there enough water in the polar caps to actually create a viable atmosphere for terraforming, or do we have to provide more water or other chemicals?
Yeah, there's 1/7 of the ancient ocean of Mars is believed to be trapped in the northern polar cap. But I must tell you that that would be very tough to get at and use. A better solution would be a buried glacier that we're now finding that's about the size of the state of the Arizona. In fact, in some locations, it's 750 meters thick. And this is the old North Pole of Mars. And Mars has quite the obliquity change. So it changes from minus 15 degrees to about 45 degrees, even though right now, today, it's at 23 degrees in terms of the rotational axis with respect to the ecliptic. So that obliquity over time has really caused tremendously different climate variations on the planet that we don't suffer because our moon keeps us nice and steady at, you know, between 24.5 and 22 degrees. And even then we have some climate changes that occur over that period of time. But that buried glacier right now is at about 42 or 45 degrees. It's a nice location. We would want our exploration zone right there and just go into a cavern where we could excavate this icy old polar cap and melt it. We wouldn't need to go to the North Polar Cap at all.
Thank you very much.
John, sorry, we have some questions from the YouTube chat. And
Well,
yeah, I am happy to say that we have 64 people listening to our workshop now. And
before we do that, could you send a message to Bob Zubrin to see if he can be located? We're going to have
Zubrin, Bob
Bob's
is
on.
already
Bob's
here.
on.
Bob is
Okay.
here.
I'm
Never
right
mind.
here.
All right.
Okay.
Our next speaker is Bob Zubrin, who founder of the Mars Society, and
Please let me put the question from the chat. So
okay.
Jan Sheptsov said, could we use this kind of magnetic shield to protect free space habitats or on the moon?
Yes, there would be the capability to do that around the moon. We haven't done any of the modeling of that, but once you're generating the current, and you can place it at a variety of locations, it then opens up these kind of new concepts. So yes, we could do it at the moon also.
Okay, thank you. Thank you very much. Please go ahead, Joe.
Please. Bob,
Oh, it's my turn to speak now?
please. Yes.
Okay. And how long do I have to speak?
10 minutes.
10?
Yeah.
Okay. All right. I want to talk a bit about the present opportunity to get humans to Mars. There is a unique opportunity right now to initiate the human exploration and settlement of Mars. This has been brought about by two facts. One is technical, in that the SpaceX Starship is on the brink of becoming operational, and this will create the much heavy lift capability, and not only heavy lift, but low cost heavy lift capability. We also have a second heavy lift capability that already exists and is high cost, which is SLS. So either way, there's heavy lift. But also, of course, we have an advocate of human settlement of Mars in perhaps the most influential position in the administration and arguably the world in the form of Elon Musk. So this creates an opportunity for such a program to be initiated. However, there are a number of problems here. One is that is a problem in the space agencies, which need to be reoriented if they are to lead this, and I think they should lead this. NASA should lead this, but it needs to be a changed NASA to lead it. And I'll come back to that. But the other is the positive and negative side of Musk. That is, Musk has defined himself as in an extremely partisan form. And if this space initiative comes to be viewed as a Elon Musk project and not an American project or a free world project, but just an Elon Musk project or a Trump project, it is likely to be destroyed as soon as political fortunes change, as they always do. Now, and that is one reason why this thing, I mean, some people have suggested, in view of the mess that NASA has made of the Artemis program, that the program should just be given to SpaceX to do. And I think that that would fail for the reason I just said. This cannot be their Mars program. It must be our Mars program. So, and furthermore, there is something else here. Okay, people talk about international or national programs. I believe that it should be international, but by international, I mean this should be a project that brings the free world together. In other words, I do not believe that this program should be one, under current circumstances, that attempts to have all the nations of the world, including Russia and China, for example, be principal members of it. But I do think it should be done by the family of nations that share the values of human freedom and dignity, and that it be used as a, or not be used, that it serve as a project that will bring the free world together, which is, in my view, fundamental strategic and ethical necessity at this time for dealing with the global challenge that we now face. Now, so the question is, can this be done? Now, I do believe that we, the space advocates, however much many of us may be frustrated with, for instance, the Artemis program, insist that this program should be led by NASA and then leading an alliance of free nations, but that the NASA's way of business be reformed for doing this. That is, the problem with the Artemis program is Artemis is not a purpose-driven mission. It is a program. It is a vendor-driven program. And that is why what you have here is a large Artemis program is composed of a large variety of individual projects, each of which have their own supporters, and somehow they're trying to make this thing fit together, and it does not fit together. It includes the Lunar Orbit Gateway, the SLS, the Orion, the National Lander, the Starship, and undoubtedly something else that escapes my attention at this point. But, for instance, the National Team Lander was awarded really for the purpose of giving a powerful constituency a contract for a lander. And NASA did not even take the trouble to force them to make it compatible with Starship. That is, if they were already funding Starship, which uses methane oxygen propellant, the utility of Starship supporting lunar expeditions would be greatly improved if there was also a star boat that used methane oxygen propellant, and you could station a Starship as a tanker in low lunar orbit, and the star boat could go up and down to the lunar surface. And you could, right now, under the current architecture and forcing Starship to use the gateway, no less, it takes 14 Starship launches with all the different tankers and refueling in different locations to support a single Starship sortie to the lunar surface and back. If you did it this way, you might need 5 or 6 Starship sorties to put a tanker in lunar orbit, but that could support 10 sorties to the lunar surface and back using a much smaller sortie vehicle. And similarly, the same starboat, if you will, could be used as a Earth return vehicle from Mars instead of the Starship, because the fundamental defect of the Starship as a return vehicle is its enormous size, and therefore the mass penalty to try to lift it from either the moon or Mars to send it back to Earth. You could send Starships one way to these locations, and you already have starter housing on them, and that's fine. It's a massive payload delivery to those locations, but it becomes seriously suboptimal as a return vehicle. And so there needs to be a return vehicle, but it needs to be made to fit with the Starship-dominated architecture. And then in this case, Orion, SLS, and Gateway, and the current National Lander, there's no need for them. My point here is that Apollo, for example, was a purpose-driven program. The purpose was not scientific, it was geostrategic. It was to astonish the world with what free people could do. But it was conceived of that way. It was not conceived of as a program to give, the Lunar Excursion Module lobby a contract, and the booster lobby a contract, and the command module lobby a contract. It was conceived of as a unified program, and then contracts were allocated for the hardware that was needed to execute it. Okay, and all sorts of people did show up when Apollo was underway, and to say, you can't do your program until you do my program. But because it was a purpose-driven program, these people were pushed out of the way. And that also has to be done in this case. But here's the thing. This is a unique opportunity, but we in the space movement, and I think many of us in the space movement, including myself, do not have politics that are similar to those of Elon Musk and Donald Trump. It is precisely our responsibility to come forward and support this program, although support it in the form that I said, so that it is not perceived of as being a Musk hobby horse or a Trump hobby horse, or an America First hobby horse, that it is conceived of as an international program that represents the best of what current human civilization has to offer, which is an open future of progress, freedom, and dignity.
Very much. That's very interesting. I did a book on Gateway in which I quoted you a number of times, and the problems with radiation and so on, in addition to everything else you've mentioned. But you've given us a lot to think about going forward. We need to go on to maintain our schedule to our next speaker, but thank you very much, Bob. You always give us insightful thoughts to think about.
All right. Well, thank you. Okay.
So we next go to Simonetta de Pippo, who was the former director of the UN Office of Outer Space Affairs, also a very high-ranking official of ESA, and now is president of D-Orbit. So Simonetta, we've given you a very big assignment of basically what to do for space governance and regulation. You're on mute.
Yeah. Okay. Now okay. Sorry. So I was saying that first of all, it's really a great pleasure to be with all of you, and so I'll go quickly through this topic that, like in the case of my previous, outstanding speakers. Well, I'll try really in just a few minutes to provide you with some highlights. So the point is that it's already true that at least space agencies and the Artemis Accords in the International Lunar Research Station agreements have been mentioned already. But at the same time, I want to underline that the space agency are really working together since now several years on trying to at least have a forum where they can discuss the relevant in the reciprocal programs. And so there is this, it's the so-called global exploration program and the global exploration architecture, which are regularly discussed by plenty of space agencies around the world. Clearly, when we do that, and so the various space agencies try to cooperate, as was mentioned before, we have some risks, so potential conflicts, resource misuse, and also environmental damage, but just to name a few of them. So, and if we look at this from the standpoint of Moon and Mars exploration, the mutual assistance and search and rescue was mentioned already. We have to establish, these are just examples, we have to establish sites for takeoff, landing, where to place our habitats. There is the issue of mining resources. Also just to support life for the people who are then on that celestial body. And when we talk about mutual assistance and search and rescue, it was mentioned again, but just to underline a few points, still the importance of international cooperation and standardization is key. We have a rescue agreement that has to be adapted to the situation, and then we need to share rescue assets. We need to have real-time communication. This was mentioned, but this is just to provide a sort of a summary. The second point that I mentioned, and again, just examples, is the issue of the sites for takeoff, landing, and habitats. And this is linked to infrastructures for lunar and Martian operations. So we have to designate certain operational zones. We have to avoid interference. And also we need international protocols for site selection. And we are far away from all of this because, as you know, the situation is completely different. We expect different countries which probably want to land in the same place, the same locations at the South Pole, because it's the place where you can find water, helium-3, other rare earths, and all the elements that may be needed for just for having the crew surviving. And then the other big question of the century, if I may, not the century, but the last few years. So the mining of resources and the opportunities and challenges linked to that. There are also some legal and ethical questions like ownership, sustainability, equity. I want just to remind everyone that the Outer Space Treaty clearly is mentioning the non-appropriation concept. So, and we could discuss about this for ages, but just to give you some elements. And also, but this is when everyone is mentioning that we do need a clear regulatory framework, otherwise we cannot go ahead properly. And so it's also evident that there are already some existing frameworks, not necessarily followed by everyone. So the Moon Agreement, the Rescue Agreement, and the Outer Space Treaty, there are a lot of important elements and topics inside. And also the Moon Agreement is even if it's just 17 countries which are supporting it, so just quite a small number if it is compared with the 193 member states of the UN, still reading it today, there are a lot of features which could be beneficial in the current situation. The Artemis Accords have been mentioned already, and there is this feature of the safety zones, which are we've been on topic for huge discussions and still are. Yeah, the idea is to try to preventing interference and promoting collaboration. And there are some, elements, some people talking about the idea of having dynamic and temporary designations for the locations. But clearly, in my opinion, the communication and transparency, what we call the transparency and confidence building measures that should be put in place in order to, I don't want to say to try to avoid, but at least to, have all these elements confined in a more, how can I say, structured manner. What is extremely important in terms of future governance of space activities is what happened at the Summit of the Future last September, and in particular, the Pact for the Future, which is the document approved at the Summit of the Future last year, which is divided into actions. And if you look at Action 56, well, you see that there is an attempt to push, in particular, the Committee on the Peaceful Uses of Outer Space to look at, principles for a framework for global governance and space traffic coordination. Again, it's not the solution, but it's going, in my opinion, in the right direction. And so, in a way, what we are trying to do here is to build the future and a future for humanity beyond Earth. And so again, it's extremely important to have, cooperation among countries, shared values. We need to see, to look at space exploration as a unified endeavor. And probably there is also the need to, if we talk about actions and a call to actions, the framework that we should create should look at the benefit and the benefits for all of humanity. Now, the current situation is evolving, is dynamic. You know that the Artemis Accords have been signed by more than 50 countries right now. And as far as we know, we have more or less 10 countries around China for the International Lunar Research Station. Now, it's not the best situation because it's like we have two pillars or two programs going in parallel, with these countries or this group of countries probably having the intention of landing the same locations, at least for what they presented officially. But at the same time, we have to consider that in the first phase of exploration, we had just two main countries, at least at the very beginning. So Soviet Union and the United States of America. Currently, if we combine the International Lunar Research Station and the Artemis program, well, altogether, we are already above 60 countries, which still is far away from the 193 that we have considered, we have, officially into the UN. But it's a very interesting element because it means that for whatever reason, we have the aggregation of countries. And now we have also to aggregate the other stakeholders. So the private sector, academia, research center, and the civil society, because at the very end, if we want to build a future beyond Earth, we need to have everyone on the same boat. So we have a lot of issues, in my opinion, a lot of actions ongoing. What I would advocate for is to speed up all the processes needed in order to have a proper framework. The sooner, the better. Thank you very much. And I've been quite on time, huh?
Thank you very much. I would just note in the Artemis Agreement, there is a provision for active debris removal. And that's not only for Earth, but also for the Moon and Mars, because with Gateway and other projects, there's a private initiative for the Moon for communications, 5 communication satellites around the Moon. So we have a problem with space debris now, but we now have to look to the Moon. So do we have time for a question?
With pleasure.
Question, Adriano, from the audience?
No, there was some question for Bob Zubrin before, but
Well,
I
all right.
would
Well,
I would
I
like
think we
to
can
ask
go ahead. We can go
Joe,
ahead.
I would like to ask one of dear Simonetta.
Yeah.
You know, one of the things we could do, also watching the talk from Tommaso, I think space rescue and recovery is going to become a critical element when we start to see many more people in space. One intermediate step could be assignment of space havens where people can stay for a while we take care of the logistics of bringing them back. And this happened already on the International Space Station. Think about Starliner going up and the crew unable to come down. Station became safe haven for them. So we may want to introduce the idea of safe haven between a direct rescue and recovery operation. What do you think?
Well, in a way, it was more generic, but it was mentioned in my presentation. So the fact that we need to have shared habitats, shared
Absolutely.
resources, and clearly standards, because otherwise, you know, even if you talk about cooperation, without all these elements, it would be, I don't want to say impossible, but extremely difficult, let's say, to obtain and to reach our goals. One thing that is extremely important to mention is that probably the system, allow me to say the system, just to be diplomatic, is not quick enough to provide with solutions because we have so many issues to deal with. And the you know, the systematic exploration of the moon, just the moon, is around the corner. It could be 1 year delay here and there, but at the very end is around the corner. And what I see is that we collectively, I mean, in particular, under the umbrella of the UN, we are wasting time, we are, you know, a little bit too slow in taking decisions and in acting in order to allow for a proper solution. It must be done step by step. I mean, clearly we cannot solve everything at the same time. This is obvious. And there are a lot of experts around the world which could help in the right direction. Like, you know, the discussions, discussion like the one today is extremely important to underline certain key elements. But there is, I mean, it's a long way to go. And the more we do it, I mean, we squeeze it, the better it is.
Excellent.
Thank you.
Thank you.
I would just note that the gateway around the moon is seen as one of its functions is to be a safe haven, but unfortunately it has a high radiation environment. So we go to our next speaker, Madhu Thangavelu.
Thangavelu, Joe.
I just remember that it was over 30 years ago that I was teaching for the first International Space University session, and you were one of the students. So time flies.
True.
So tell us about the moon and what we can do with the cavities on the moon.
Okay, and are we on?
Yes.
Adriano, can you see my slides?
Yes.
Oh, great. So as Joe mentioned, I was a student of some of you on this list over here, and I'm so happy to hear your voices. In fact, I know most of you personally, and as maybe one or two, we could meet and have tea and discuss over dinner or something like that. But anyhow, it is so nice to be among you. I prepared a lecture for my students, which I'm going to run through the slides here, talk to a few bullets, and leave the set with Adriano and with Joe for you all to refer to and comment on. So the scope is we'll talk a little bit about USC astronautics, a little bit of brief history about the lava tubes and the rationale for it, the current status, future, and a little bit of philosophy is important because I was trained in architecture and engineering, and architects are deep in philosophy. Without a philosophy, you can do nothing, as you know. So USC Astronautics is a very selective and small program within USC. And our favorite alum has always been Neil Armstrong. And in it is my studio, which has been running for some 30 some years now. And it's all focused on one thing alone: imagination and creativity. In the second semester, I teach in the School of Architecture, where I meet a very different group than engineers. Architects are down-to-earth people. They need to have creativity and concepts on their fingertips to be able to perform their work. So they ask questions that are very, very different from what engineers ask. You can go into these books that have just been published. It's got chapters on how we think space architecture can help the space engineer. And I thought I'd put these in for all of you to look at. They are interesting books. We have great friends here in the Southland. Well, it's burning out there in Los Angeles, so we are safe on the other side of the bay. Buzz Aldrin is a good friend of the studio. We get a lot of people coming in from various parts of the world. Here we see a group from UCL London, and they come in because my lectures are in the evening. We host them to sit and do interesting talks. The studio has expanded from a small studio to a global audience now. So mainly the theme is imagine a concept and present it to the world. If everybody did that, or let's say 1% of humanity did that, we would all be in better shape. So the focus is on things that are happening now. So if you're coming into a class hoping to read up a textbook and do well, you better think twice, because you better train yourselves in concepts of things happening now. When I say things happening now, what do I mean? Have you read up and understood and followed the works like Scott Page's New Era Deep Space Exploration, or the very recent from this administration's work by Norm Augustine? These are the things we ask in the class and work with. So why, when, and where? These are the things, and how much, and how much, and how much, and how is done in engineering, which we have very beautiful courses in, but we do more about why, when, and where. This is our book, the second edition. Third edition is in the works, expected in July. And Buzz Aldrin wrote the foreword for our book in the second edition. In the second edition, you'll find a focus, a look on lava tubes on the moon. This is a drawing I did way back in 1999, when we did not know many things about the moon. So here you see Buzz Aldrin coming to studio. And this semester, this fall semester that just ended, we were thinking deeply about the future of our space station and human spaceflight in particular. Please go in and take a look at our studio archives to know what we've been doing for the last 30 some years. And I hope you enjoy this. So let me go into a brief history of lava tubes. A lot of people have been talking about lava tubes, and I got introduced during Wendell Mendel's talk at the International Space University, where Joe was training us on remote sensing and the works that he was doing at the Intelsat. Now, in 2007, something very interesting happened. A Japanese spacecraft was put into orbit, and it located what seemed to be an aperture on the moon. Quickly, the LRO went ahead and resolved it and got some very interesting ideas. And we are still hunting for more and more of these apertures. We call them skylights and lunar pits, and they're all over the moon. And these are some of the images. And then in 2012, the Grail mission flown by Maria Zuber SPI from MIT, it did some very interesting things, looked at the moon to see what kind of cavities exist. Lo and behold, the moon is full of cavities. And so Wallace and Gromit is right. The moon is made of cheese. So rationale, why lava tubes? The why question is the most important question that architects usually answer better than all the engineers on planet Earth. Why we do something, it has deep roots in philosophy and the human psyche. Why we do it on the moon is because the moon is not the Earth, folks. There is no atmosphere. Every time you see a shooting star, some parts of it are probably hitting the moon. And by looking at cameras, looking out at the moon, we see so many of them in such a short time. So moon is being pummeled by micrometeorites, meteorites all the time. So the moon, lunar surface is not Hawaii. There is vacuum. It's low gravity. There's radiation, deep thermal cycling, and the sun stays there a long time in the sky, 28 times longer than on Earth. And these showers are very dangerous, and the impacts can take out assets very quickly. So rescue and safe havens are very important. If you look at the temperature, and a very recent paper from China on the right tells you how radiation can be affected by going deep underground. So lava tubes come to the rescue. One more thing that came in discussions recently is that if you go underground, you have very sturdy structures, as Melosh and others have pointed out, but also their suits would be very, very different and more comfortable because you are not faced with the harsh radiation and the harsh climate on the surface.
Madhu, you are 2 minutes over time.
Oh, but over time? Oh my goodness! Sorry. So, so potential users are many, and I'm going to leave these slides with Joe so that he can really look at them. So current status is lava tubes are plenty. I think our next speaker may talk about it, and some wonderful things have been happening in Hawaii. JPL has been doing some interesting things. Pascalle at NASA Ames been doing some things. And most importantly, China has been doing very interesting things, folks. You want to study what China is doing. Very, very useful for studying what and they are the only ones who've done anything dealing with timelines. And as Norm Augustine says, without timelines, you can't do any engineering. So what's the future? We got creators, we got beautiful things happening. I'm playing with AI to create images. And all this was go with Joe so that he can do some things. SpaceX, watch out. They're going to do some magical things, folks. My own professor told me that you have to instrument the planet to be able to do something good. These are the vehicles that are coming in. The philosophy is always there, folks. Read about it. Without it, you cannot do any engineering. And this is what happened with our administrator during this presentation.
you very much. We do have to go on.
There we go. Yep, this is it, folks. I'm going to drop this with Joe so that he knows how to circulate it. Some fascinating things happening, and ISS recommendations, and our wonderful bibliography. Thank you, Joe, for bearing with it.
Right. Thank you very much. We will try to get these presentations online. So our next speaker is Henk Rogers, who heads the International Moon Base Alliance, and he is a natural follow-on to Madhu's talk because he's doing very exciting things in terms of simulating living in space.
Henk is the only person I know who has done some real lava tube exploration. I hope he talks about it.
Okay, Henk.
All right. So my talk is about why do we go? And I'll start with the conversation I had with my daughter. And my daughter said to me, "Pops, why do you want to go to the moon? And why do you want to go to Mars?" And I said, well, what's the problem? I mean, it's exploration. It's the natural next step for humanity. And she said, we have done such a piss poor job of taking care of this planet. You know, what makes you think that you have the right to go and mess up another planet? And, you know, and I explained to her, I said, look, the universe or the galaxy or however you want to look at it, just imagine it being an almost infinite beach with an infinite number of grains of sand. And one of those grains of sand actually has a little green smudge on it, and that is life as we know it. What if we managed to get another grain of sand to have another smudge? Would that, in the universe of things, make that big of a difference? The answer is no. So I think from the perspective of let's not mess things up, I don't think we can possibly mess things up. My background is I'm a science fiction fan. You know, I grew up on Star Trek, read all the Heinlein Foundation, doing all of that stuff. And so I've always, you know, had the desire to have us go to space. But if we don't give people a good reason why we go, they will not let us go. They will not fund us. They will not, you know, there'll be some guys in Congress who say exactly what my daughter said. Why are we wasting all this money on going to space when our own planet is going to hell in a handbasket? So we have to think about this, and we have to think about this hard because it feels like our community, we are all thinking about how to go, and we're not explaining ourselves to the rest of humanity as to why we should go. I got on the track of making my mission. My mission is to make a backup of life by going to other planets. I got on this mission after I had a 100% blockage of the widowmaker, which is a malady that happens to your heart, and 95% of the people that have that malady die. I'm the lucky 5%. In the ambulance, I said, no, I'm not going. I still have stuff to do. And in the recovery room, I started thinking, what are my missions in life? And one of my missions turned into be, we have to make a backup of life because we are vulnerable. And I may disagree with Elon about a lot of things, but one of the things that he gives as a reason is there's a finite number that says that we are, planet Earth could be destroyed, or life as we know it on planet Earth could be destroyed. But if we have a backup, if we have another planet, then at least that probability goes down to zero. In any case, I explain it to my daughter, and I'm not sure that I've won her over, but I look at life as we know it as being one thing, all of life. And you can call it Gaia, you can call it Mother Nature, I really don't care what you call it. But it's one thing. And we are just maybe the brain cells, but we can't live without all the other life on planet Earth. That's for sure. And so the valuable thing about going to space, going to other planets, may not be for us to go, but for life as we know it to go. And Mother Nature, in my humble opinion, is pregnant, and we are it. We are the way that Mother Nature has a baby, which is another planet. Because right now, as far as we know, she's all here. She's never been anywhere else. And well, maybe on Mars, but it's really up to us to go somewhere and throw out the garbage. So to that end, I've been involved in doing things. And as Madhu says, I have an analog on the Big Island called High Seas, the Hawaii Space Exploration Analog and Simulation, where we test people living on other planets. The first 5 years was with NASA. NASA funded a bunch of Mars missions. We had 5 missions, 4 months, 4 months, 8 months, 12 months, and 8 months. A mission means 6 people stay inside a 1,200 square foot dome. If they go outside, they have to wear a spacesuit, a simulated spacesuit. And if they communicate with the outside world, we delay that signal 20 minutes each way. Now, these missions were basically about crew psychology and crew selection. I can tell you, NASA made all the crew selection, and they sucked at it because there were some serious mistakes in their crew selection. We didn't have any like major accidents, but we did have all kinds of problems because of crew selection. And people, when they go through the selection process, as you know, astronauts, they freaking lie and to get to go to space. Because if you tell the truth, they'll find some reason for you not to go. So you've got to be lying your ass off. And so we did have all of those mistakes. In any case, we switched from doing Mars missions to moon missions when NASA got out of the picture, and we've been doing 1-2 week missions with no delay on the communication. And my idea is to give more people, as many people as possible, the experience of going to space. Because the more people that we give that experience to, the more people are going to say, yeah, I think it's a good idea that we should go, especially young people. So my message to the community is, let's make sure that we pay attention. And I'm not saying my reason is the right reason or the only reason. There's probably many reasons, but we have to have a reason that other people buy, or we don't get to go. We don't get funded. And things are going to get worse back on Earth. I mean, you look at the fire in California, in Hawaii, California, you look at the floods, you look at all these things that are happening. These are top of mind now. And they're going to become more top of mind as we go forward. So even if we want to build a moon base or a space elevator, we have to think of a really good reason why we get to do this. The last thing I'd like to say, I'm giving my extra time back, is I spent time on a Polynesian voyaging canoe called Hokulea. And Hokulea is a replica of the voyaging canoes that first discovered Hawaii, I don't know, maybe 1,000 years ago. And these things were double hull canoes, sailing ships, and they sailed by celestial navigation under the most insane conditions. And they found Hawaii and colonized Hawaii. So in this recreation, part of it is, of course, the celestial navigation part. And that's very wonderful that we can actually travel the Pacific without any instruments, just by looking at the sun, the moon, the wind, the waves, the birds for navigation. And they find from Hawaii to Tahiti, which is basically, if you're off by one degree, you miss Tahiti altogether. But anyway, I believe what they've rediscovered is not navigation, but voyaging. And that voyaging thing, when we go, we have to go with respect. We have to go and say, when we go, we're not going there to take over the place or destroy the place or own the place. We are going there and we are going to be stewards. And there's a saying that says, leave only footprints. well, I hate to say this, but on the moon, footprints are forever. And so I really think that when we go to explain why we should get to go, we should also explain how we're going to preserve the surface of the moon without like making tire tracks and everything everywhere. So please keep that in mind when we go to the moon. We have to be good stewards. So thank you very much.
Thanks, Henk.
Thank you, Henk. Yes,
one of
I would have some question, because it's always very interesting to discuss with Henk, and we make it one per year when we meet in New York last 2 years. However, I have an answer very simple now to the question why we should go, because the world is blasting, and we have horrible wars where 100,000 people are killed, and the people is tired even to protest against that, and nobody is saying anything with so many children killed, and things very bad that happens. What does it mean? That we are running the risk of a very bad cultural degrowth, a cultural back in the history, no? Because people now is feeling in their bone, even if they have a rationale for that, but they feel in their bones that we are closed in a cage, in a philosophical cage. So if we don't open a new horizon for development, the civilization really risk a very bad implosion. And so I think this is more evident to see now. We were saying these things 10 years ago, and people said, no, you have to think about the positive, you have to make a positive narration, not a catastrophic one. But now the catastrophe is here. So I think it is evident what we were saying.
Thank you, Adriano. You seem to have got the question and the answer together. But you want to just mention Henk is on our steering committee, as well as Madhu, and our next speaker has played a key role as well. He is Gary Barnhard has his Space Development Foundation, and also with the National Space Society and Moon Village Association. So he lives this every day of his life. Gary, tell us about the future and the anthropology of space.
Okay, great. Thank you very much, Joe. Appreciate the opportunity to be here. My talk today is on the off-world. Let me get the slides to share here. That would be a nice thing. Actually, it's not giving me the ability. Hold on. We'll kick this over. There's the share. And we go to that screen. And we go to full screen. Hopefully here in a moment, as soon as I get the zoom bar off the view. And okay, it kicked it to the wrong side, so bear with me a moment and we'll kick it over between the views here. And we have succeeded. Do you see the screen yet?
This is readable, Gary.
Okay, and it should be more than readable. It should.
Full screen, Gary.
It's not
Yeah,
full screen.
Full screen.
That's what I'm telling it to do. And the full screen. So
You
share.
can tell Gary's using a Mac.
No, actually, I'm not. It's a
all right.
PC, but it's not my normal
Is a function.
regards.
Okay, function F5. Function F5. If you have a Microsoft machine.
Yeah.
Function F5.
Okay, and trick is, of course, it's 2 screens. So let's go through and we'll cause it.
Or also you have the last icon on the bottom right. The last icon on the bottom right. Yeah, that one. Click.
Yep. And it's there.
No?
The trick is it's showing
Doesn't
up
work.
on.
Why not?
It
Strange.
is. Bear with me a moment. I have multiple screens is what the issue is. So it'll be right back, and then it will be happy. The share. And we use this screen, entire screen, share. Okay, and this goes there.
Double click to enter full screen was written.
Yep. Okay, so you should see. And sorry, it's not gonna go there with the double screens, so life goes on. Let's try that. Now it'll do it. I unplugged the extra screen. Okay, great.
Oh, great.
All right, so my talk today is going to be on the off-world, anthropological space infrastructure settlement, the OASIS project, whose objective is fostering cooperation, collaboration, and competition. Where we're coming from with this is that this began as a Kepler Space University initiative to develop a prototype simulation analog for sustainable lunar settlement. It's evolved into a cooperative, collaborative, and competitive space preliminary and conceptual engineering modeling endeavor. The principal objective is to explore how outcome-based programs driven by known science, systems engineering, and architectural design can maximize the probability of mission success. There's also been a OASIS 2045 project that resulted in a case study on potential lunar human settlement that came out of the Moon Village Association Architectural Concepts and Considerations Working Group. And it turns out OASIS is a popular name for many habitation studies over the years. The scenario that we're looking at is, if you can suspend disbelief for a moment, that the signatories of the Artemis Accords, united in their collective determination, have set their sights on a successful development of sustainable off-world human settlements as a shared goal that must be realized. Furthermore, this goal is best served by a combination of cooperation, collaboration, and competition. This effort to architect, engineer, and implement anthropologically sound space infrastructure for settlement purposes is intended to support a realized arcology. The project objectives are to manage the cost, schedule, and technical risk of the same in a manner that it allows it to be actualized within a decade. And actualization can be direct implementation or infusion into other nation, state, and commercial lunar infrastructure projects. We see it as splitting up between a phase 0 activity, which is analog and robotic testing, both on Earth and space, where science-driven requirements dominate. Phase 1, where there's in situ testing of subscale elements and distributed systems, and systems engineering-driven requirements dominate. And then phase 2, the at-scale deployment, which is where the architecture-driven requirements dominate. The science-driven requirements that address the physical conditions on the lunar surface, e.g. radiation, temperature, regolith material that make up the moon, must be established and verified based on ground truth as the highest priority. The results cascade through all the subsequent phases. As some of our earlier speakers have mentioned, this is this notion of arcology is the shared understanding of the relationship between life, the natural environment, and the built environment. The concept was championed by Paulo Soleri, a visionary architect. Human beings don't go alone. We actually travel with our own biome, and there's multiple genuses associated with life that we have to contend with. There is in terms of our understanding of the natural environment, it becomes a critical deal, and what we do with respect to the built environment. When you look at what that means and what we've been doing in the Oasis project is looking at these different different breakouts and finding what is it that we know and what we know we don't know in each of these areas, and how does it end up fitting together. That web of relationships is what we are attempting to pull together on a cooperative and collaborative basis. There's a set of driving requirements associated with both the science, the systems engineering, and the architecture, all of which, when they're cascaded and intersected together, create multiple opportunities for synergy and to help us better understand both the problem space and the potential solution space. We look at it from the standpoint of, since we want systems that can, not only fail safe, but fail safe passively. We looked towards the lunar sky vent environments as an opportunity that we can leverage a significant infrastructure that stacks the deck in favor of more opportunities as opposed to making the problem harder. We thought of it in terms of what are the key interfaces that have to be contended with. There's a sky to atrium interface that involves tensegrity structures that needs a high degree of transparency and modularity. There's an atrium to reflector interface that's required because you not only want to have to deal with artificial light, but you want to be able to provide for natural light as well, which involves, again, tensegrity structures, highly reflective structures, regular shielding, and the necessary mechanical corridor penetrations. Then there's the atrium to atrium interfaces of how you go and provide for gossamer structures and the light paths, and the quadrant of 4, which is really the regolith to mechanical. So there's a whole range of structural elements that we contend with. This is an example of the phase 1 architecture that we're working with, showing a canopy and a structure within an adjacent crater to a sky vent environment. And then as we go through and look at how we transition from what can be launched in, say, a Starship or a New Glenn environment to in the human lander systems, we have to look at both the stowed payload envelopes, what are credible deployed envelopes that take advantage of the fact that you have both static elements of your structure, you have unfurlable elements, and you have inflatable elements in order to maximize the utility and then how you make the connections between them. We went through and this is a notional cross section of what we were looking at that shows how we provided both for passive radiation protection, artificial and natural illumination, and enabled a self-supporting, self-sustaining structural environment. By effectively building what amounts to being a structural platform across the surface of the truss, across the surface of the sky vent, so you could have a self-supporting, self-sustaining structure. I'm going to go through and this entire presentation, which has many slides associated with it, is actually going to be made available. But I just wanted to provide an introduction to where we're coming through with this and showing how you could go through and evolve these from the stowed habitat module elements up through multiple deployed levels and the establishing the relationship of in terms of the tessellation of those structures. And this was a connectivity study. The volume is not is purely notional here, but the question is the connectivity and the fact that there has to be relationships between different kinds of spaces. Private spaces, workspaces, shared spaces, provisions for mobility that have to all be contended with, and the scar for expansion.
Thank you very much.
This is the end, last slide. Basically, with respect to the OASIS mission, we're trying to translate all we know and can come to learn into a realized arcology for sustainable settlements in cislunar space and beyond. This can enable us to be the best stewards we can of our Earth and life as we know it, wherever we choose to provide for it. And these are some of the nonprofit organizations that are currently involved in the OASIS effort and in those capacities. And there's a bunch of backup sites, which I'd recommend you, if this interests you, that you check it out. Thank you very much.
Thanks, Gary. It was really fascinating, but we need to move quickly to our next speaker. That's Dr. Pascalle Efrenfreund. I'm sorry, of course. Anyway, she is currently president of COSPAR. She is also associated with George Washington University, where I taught for many years. And she was also president of International Space University, and I could go on and on. But anyway, tell us about the challenges of living in space and what we should be doing. Pascalle, you're on mute.
Mute. Yes, thank you very much. And I'm gonna dive right in. Let me just see. I think it was discussed a lot, and I liked also the angle of the space economy because it is not really clear if we will have a cislunar economy. Some people are really very skeptical, and it was quite interesting. And I'm going to read the book which was mentioned previously. But something what is really clear is that we have an amazing amount of space missions going into the solar system that has never happened before, and be it Moon, Mars, bringing back samples from asteroids, looking at exoplanets going into the outer solar system. So this is quite amazing. And when we are looking at human exploration, of course, there is I'm going a bit too fast. There is a lot of experiments which are done on the International Space Station, in particular also for studying the challenges living in space, like, for instance, the immune system, looking at AI, having an AI companion, and studying telerobotic. And I think many of those topics will be discussed by the next speaker. But we have the International Space Station, 20 years habitation, 3,000 experiments with scientists in 100 countries. So this is an area which is going to end, and we will have very likely commercial space stations, probably not 4 as mentioned here, but maybe hopefully 1 and probably 2. And I think that's a very important step, because all those plannings for those kind of commercial space stations really include also to be open also to society, not only scientists and commercials, but also, for space flight. And looking at the numbers, I think this is Nova Space now, but this is still a report from last year under Euroconsult, shows this, also this trend of increasing growth of space exploration economy. However, the estimates are approximately in the next 10 years to be, I think by 2033 or so, 32 billion, which is invested. So that's a bit different than, we're looking at Earth's orbit, but still a lot of missions, and you can actually see that by category. And something what we have recently published, a figure from Price Tech, is that in the planning stage, there are more than 150 missions to the moon and cislunar orbit, and also trying to promote the cislunar economy. So not all of them will fly, but it's quite amazing, what's going on in the public and private sector. So long-term space missions are a big challenge because we have to try to have decades, and create outposts, habitats, invent new technologies. So there's a lot to do. And in particular, concerning human space exploration, there are many factors which are not well studied. And I go right directly into this really, really nice paper, which everybody can get from Nature, from medicine people, not space people, which show really the 5 hazards and discuss really in detail what the radiation does to you, what the confinement does to you, distance. We have really a lot of medical problems, and I don't want to go too much into detail because I think my speaker after me, but there are so many problems. And what I really want to say is that we don't know so many things, and saying that in 10 years we will bring people to Mars, this is something which is gonna not work out, because we have to do a lot of research and also into new materials. So the biggest culprit is the radiation right now, and that we have an increased cancer risk by approximately 1 Sievert of a doses of a lifetime. And the last Mars missions have actually shown that we receive about 60% of the allowed lifetime radiation dose already during the travel to Mars. And that doesn't include much else or stay. So I think this is something, and there are a lot of papers, and I think this is something we really have to focus on. We have to define new materials, how we can really protect ourselves. As you know, there are 2 main types of radiation: solar energetic particles and also galactic cosmic rays. And there are quite some ideas how you should actually schedule missions, according to when we have a solar maximum or not. And that we need shielding, and this has been quite well studied and will be well studied. And the last conclusion is the shortest Earth to Mars flight times will be in 2030 and also in 2050, corresponding also to periods of solar maximum where it's most safest. So there is a lot of things we have to learn and to study in order to protect us, because that's a real bottleneck, the radiation for human exploration. And I still want to show one of the because it was mentioned before, how do we feed ourselves? And there are also a lot of interesting experiments, and this is the Eden experiment from DLR with a lot of partners, where they have actually studied in the Antarctica, and grown fresh vegetables. I've heard they were extremely popular because all the adjacent, stations have been going there to get food, and has been very successful experiment how to grow actually in a very, very difficult environment and extreme environment. So this is also something, life support is something which is really, really crucial in the future. And I want to end, I don't know how much time I still have, with something which has been mentioned in several discussions already, about sustainable space exploration activities. When we go there, we really, really want to be careful, and we want to preserve. And Simonetta was also a part of the World Economic Forum. We published this blog, which you can get, how we focused on the moon. And we looked at some imperatives, to build a comprehensive space-related environmental database to align the space stakeholders, drive to consensus building on harmful contamination, because not even that we have yet defined, to incorporate really the newest science finding into policies. That's what also, you know, COSPAR is trying to do, and enhance transparency, coordinate regularity mechanisms, what Simonetta was talking about, and also conduct public awareness campaigns. What are we doing and where are we going? So this is more or less what I think there are many papers on this subject, but in brief, this is really sustainability of space exploration. If we go further, is a very important topic. And I just want to end to say that COSPAR is working a lot on many of those topics which are important for preservation, like planetary protection, environmental stewardship, and also in collaboration with the United Nations. And I just want to complete my talk by saying that it is really crucial with this. We don't know yet what's really going to happen. We don't know if we have really a full-fledged cislunar economy, but what is clear is that there are many missions which are planned and that we have to coordinate better. It is a multi-stakeholder approach. We have to have a good dialogue, and we have to look at be responsible for the future. Thank you.
Thank you very much, Pascalle. It's by accident that we have only our two of our women speakers, the penultimate and last, but that's because they are the best. So I would like to introduce Dr. Jewell. Susan Jewell is a person I first met in Montreal at the International Space University, and she's gone on to do amazing things with her Mars group that she's going to tell us about, and also living in space. So it's all yours, Dr. Jewell.
Thank you so much, Joe, and thanks everyone. Being the last but not the least, let me share my presentation. Can you see my presentation?
Not yet.
How about now?
No.
No? Okay, let's go back to the Zoom. Let's see, share. Oh, here it is. All right. Okay, can you see it now? Yes, no? Fantastic. Okay, let me go to the beginning. All right, now you can see the full screen of the slide, correct?
Yes, we can.
Okay, fantastic. Well, that's the title. It's long and I'm not going to repeat it. But basically, if we are going to live in space, we don't only want to survive in space, right? We want to thrive in space. And being humans, we're very fragile, and we've got to take care of the humans in space. So if we're really going to manifest that vision of becoming multiplanetary, and the whole idea of settlement on a dangerous environment like space or on a planet surface, we've got to develop the capability to support humans to thrive. And that is what I've been doing for nearly over a decade. I remember first when I went to all these space conferences and they were all talking about engineering, rocketry, which is great. But then I bring up the subject of how do you keep the humans, the astronauts alive? And they say, well, we'll talk about that when the time comes. Because that was very early when we didn't even talk about commercial astronautics or commercial space tourism or just normal people wanting to go to space. Okay, so that's my introduction. And also I want to say, why do we want to explore space? And what Henk said, and trying to explain to her daughters, what I try to explain to my children and all the younger generation is space is a place for innovation and for trying to develop new ideas that not only enable us to go to space, but also to improve life on Earth. I think that is the real link of why we want to do space exploration. So medicine and health is important. As Pascalle said, thank you for introducing why we need to look at space health medicine. it's because we want to create the technology, create the paradigms to be able to enable us to stay alive. So for me, MMARS, and by the way, I want a full disclosure, and I only have like 9 minutes left. So we've done a lot of technology innovation in this sector. And so I'm just going to skim through all the slides very fast. If you want to know more detail, you can reach out to me, or you can go to our website. But all the things I'm going to present was, this is disclosure, was funded and sponsored by my two companies, MMARS and Avatar Medic. So MMARS have been deploying analog missions in austere environments, and we have our own training facility, Mojave Desert in California. And now we are actually expanding that facility to develop the very first, what we call SMARTY, the Space Medicine Biotech Analog Astronaut Research Training and Education. And the whole idea is that you want to engage people. And if they don't have an interactive, hands-on experiential learning, you're never going to engage anyone. And to fully understand the complexity of what it entails is for them, as Henk said, to experience it themselves. And that's what, we're trying to also do, to develop this facility that is very focused on the medical technology, on giving the individuals experience of what it is, and training the future generation of space medicine doctors and space medics. So we've been doing this for nearly over 12 years. We've gone to austere environments. Here you can see training space medics, and this is a whole program we've developed over the last decade. We've gone to like Nepal, there at 10,000 feet, 15,000 feet, the first only full Mars medic simulation. We've brought in telerobotics to train, to bring in remote surgeons, remote doctors to come in and train. And this is the important part, non-medical individuals in the crews. And the question is, we're trying to answer is, can we train these non-medical individuals to acquire the medical knowledge, attain this medical knowledge, to be able to help the crew if they were facing a life-threatening emergency? That's the key, life-threatening. If you have indigestion, okay, it's not life-threatening, one hopes. But if it's life-threatening, you're going to have the capabilities, the skills, the expertise to be able to save the life of that person. And that is what my main mission is, to develop these programs. And so the next one is, we pioneered back in 2014 with the Antarctica medical team, the very first tele-anesthesia, telesurgery. I'm not going to go into detail because I don't have much time, but here we actually worked with the medical team. We had the non-medical crew at Mars Desert Research Station, which is the Mars Society there in Utah Station. And we had the medical team actually tele-mentoring the non-medical crew how to do tele-anesthesia, telesurgery. And we had a very high fidelity mannequin that had this, remember this is back in 2014, right? Technology was still in this point, it's still very infancy. But the main point of this was to actually conduct a tele-mentoring session, tele-mentoring the crews how to acquire the knowledge. And then, of course, over the years, in 2019, we came out of the Anna Avatar X Prize with Avatar Medic. And here we're looking at robotics. And we started developing, robots. And of course, in the last 6 years, look where we're at with humanoid robots, with Tesla robots, and also one which you all look at, it's called Figure. And they actually have been selling them to commercial clients, humanoid robots. That is sort of where I see the support of humans in dangerous environments. Is not that we're going to have robots, doing the missions. They will be adjunct, or they're going to complement the crews. Or in our case, what we did was we bought in, and this is a 3D, fully 3D robotic arm, and it was connected with augmented reality. We had surgeons coming in or doctors coming in and helping to train the crews with them as tele-avatars. And here was just very early days of a space clinic idea that we're just prototyping and testing out in the Mojave Desert. So we also started, because this is pre-COVID time, where it's actually during the height of the COVID, and where a lot of the frontline doctors were dying because they were contracting COVID from the patients. So we started developing a tele-avatar robot. Here you could see, but I'm not going to go into all this. You can go on the website, you can see all the demos and how we were doing that. And here you could see, actually, there's me there coming in as a tele-avatar and coming in for the patient, teaching how to do a simple neurological exam. And what we've also been working on the last few years is what we called embodiment tele-avatars. And in this case, this is actually the first development using AI and using LLM, large language models, training the system how to come in as a astropsychiatrist, a psychologist, coming as a tele-avatar embodied. So this is the future of where you can say science fiction coming in, that is going into sort of the holodeck and having a full immersive simulation, but you're interacting with the expert. In this case, it's a psychologist and a psychiatrist. And we're also training the platform on what we call the gold standard Bible of therapeutic diagnostic for mental health, right? Because if we are going to live long-term in space, we are going to see psychiatric issues that we will encounter. And how do you address that? We're in altered gravity, so we all know that Pascalle said it alters all the systems in our body. So we can't use what we have developed here on 1G when we are on altered G in a different altered environment. So that's a very, I think, interesting future of where the application of AI and LLM is going to come in. And so here I'm just going to show you. Digital twinning is also another technology that's been embraced in many sectors. And what we've done as a proof of concept was, how can we train the crews or remote teams to use this technology? And I'm going to just play this, if you can see. So what we did was, using XR, this is the HoloLens 2, we digital twin the 3D robotic arm. This is the digital twin. We gave it a scenario, in this case, picking up an instrument, picking up whatever it is you want what the digital arm to do. And then using the XR, which is extended reality, we have, superimposed on the palm, the control system, and then with the coding system, been able to communicate with the digital arm, virtual arm, to the real arm. The real arm actually maneuvered and did the same task as the digital arm. This is the basic concept of what digital twinning is. You can see the potential of this technology, where you don't need to have the human there in person in real time. Well, they're with them in real time, but they're remote, right? And they're able to maneuver the robot arm to be able to do the tasks that you want. And that is where I think the innovation comes in. And I think this is where you're going to overcome a lot of the problems of how do you interact with somebody that is injured or need medical care. The physicians, the doctors can come in remotely using this technology. I'm nearly done. So here was interesting. Last year, we actually had NASA teleported a surgeon onto the ISS, but they were just proving that concept using the HoloLens, the XR headset. But what we've done is, and you can see on the right, we actually developed, and this is nearly 3 years old, is how do you train individuals to do basic life support, to do first aid, advanced life support. We developed this platform called Holo Triage. It's triaging and training them using this technology as avatars, and then you have all these different scenarios that they can engage in and learn in a full simulation. And then another one is we developed the very first solar-powered 3D printer that we test out in all austere environments. But the main point of this, now you can print whatever you want off-grid. Okay, so we've been doing this for several years, but now what we're looking at is how to make this into a solar-powered a 3D bioprinter. And that, I think, is what's so exciting, because obviously in any austere environments, remote, limited resource, limited supply chain, you're going to have, if you can have the technology to have on-site, immediate, real-time, for example, tissues, organs, whatever it is, you can do this off-grid, right? Of course, you're going to need the sun, but we have plenty of sun in space. So in this case, we're looking at this very early development of this technology to do drug discovery, to do space pharmaceuticals. I mean, that is the interesting aspect of where I think this technology can do for us, right, is to be able to say we develop the drugs in space. We can do drug discovery, we can do tissue on a chip, and so on and so forth. Anyway, this is really interesting, which is a lot of funding right now, and in this space for NASA. And then you could see what we've been doing, you know, developing medical tools and training the crews how to integrate those medical tools they design into their telesurgery, teleanesthesia. 2 more slides. Here we also work on bringing in, and this is what you need to do if you want to engage people who are not interested in space or not interested in engineering. You bring the civilians in and to engage them. Yes?
Susan, you are 3 minutes over time.
Okay. Yes, this is my last slide. So this 2 slides is really bringing in individuals using gamification, using AR, and they can come in as digital astronauts or digital space doctors, and they can learn in this way. So 10 minutes, I really go fast, but thank you so much. That was a lot, but I hope you enjoyed it. Thank you so much.
Well, thank you all the speakers. I really appreciate the breadth and depth of the 10-minute sessions. We will have a workshop where people will be able to present papers in more detail. On the 13th of February, we'll have our next session, and hopefully we will, as we did in this case, had all of our speakers able to speak and giving us very cogent and informative materials. I don't know whether Adriano could cue up the video that we were supposed to start this session with the 2001 theme song with it, but that would be a nice way to close out. But thank you all members of the steering committee as well as the ops committee that made this all happen today. Can we play the video?
Thank you, Joe. Are we going to get all these slide decks together and
yes,
so that we can access them?
Those would all be on the Living in Space, living-in-space.org website where we will hopefully have all of these materials, as also all of our steering committee members and the website. So can we play the video as we close out? We don't have the video, I mean the audio. Imagine the 2001 theme song. Thus spake Zarathustra.
Okay. So thank you very much, everybody, for being with us. See you next time. Ad Astra.
All right.
Thank you.
Thank you.
Adios.
Thank you.
Bye.